Hello! Welcome to the stream. David Snowpeck here from Snowpeck Games. Looks like we got a couple of eyeballs going. Of course, I don't know who really is there unless you say something in chat, and of course that will also spawn a little character for you in our custom stream overlay that we made in Godot. Let me press the keys I need to press to actually show that as an overlay. Hey, Inferno5544! Welcome to the stream. Whoa, you got a sweet beard. I think my character and your character are wearing the same shirt, but you definitely won on the beard. All right. How's everyone doing? How's everyone's week going? How are your game dev projects going? Let me know in the chat while I try and remember the buttons I have to press to, there we go, to start to switch this overlay on as an actual overlay rather than just being my full screen here. The Clean, hey, how's it going? And I think I have to hit, ooh, that didn't work, did it? All right, let's try again. Oh my gosh, I need to like script this on my desktop or something so I don't have to try and do it each time and introduce error-prone human beings. Stupid humans. Stream tools and make it full screen over here. Go back to OBS, turn it on, and you guys will have to let me know if that is working, if you're seeing the little people over me or if I'm blacked out or what's going on. All right, no one is letting me know how their projects are going. I would love to hear about your guys' game dev projects. Feel free to self-promote, as long as you're self-promoting game dev stuff. Self-promoting other stuff, maybe, you know, it's a little suspect. But for anyone who is new to the stream, just a quick overview of what we have been working on for the last couple of months. Actually, we have been working on converting my retro tank party game to rollback and prediction-based netcode, which is what is commonly used in competitive fighting games, popularized by the GGPO library. And we've gotten, you know, the netcode more or less done, and now we've been addressing deterministic physics, because this network synchronization technique only works if your physics are deterministic, and Godot's built-in physics engine is not. So we've been implementing our own custom physics engine as a Godot module in C++ that we are then, you know, exposing to GDScript so that the game, which is primarily written in GDScript, can use it. So last time, we were finally working on integrating this physics engine into the game itself, and we had hit a bug at the end of the last stream. Nobody's telling me that they're not seeing me, so I'll take that as a good sign. No news is good news. Where you would just drive right through these trees. We had tried to convert these big trees to the new physics engine, and you just drove right through them. And we discovered that the reason that is because the little trees still don't work. We were creating the shape used by the physics engine, the internal shape object, for each shape resource in Godot. And because Godot creates each resource only once and then kind of shares it everywhere that it's used, that was only creating a single shape, so only one tree in the scene was getting the shape. And I fixed that, as you can see. All of the big trees are now colliding, and it was a relatively simple change. I can show you the code in C++ for it. This is some other stuff. This is what I was working on last, and what we will continue working on today, this fixed transform 2D. But that was in resources. So we have this SG shape resource, which holds the kind of shape that you create in engine. So like, let me go to our tank, or let me go to our test physics scene. That'll be easier for me to find my way around, because it's considerably less complicated. So we have our SG collision shape node, which takes a shape resource here. And previously, this resource was creating a single instance of the internal shape object and was managing its memory and its lifecycle and all that stuff. So only one would ever be created, and we've moved that now to have these shape classes have a create internal shape method, which they each implement. So the rectangle creates an internal rectangle, circle creates an internal circle, and it is now the SG collision shape 2D object that is managing the life cycle. So you can kind of see when, where is it doing its magic? No, this is the wrong thing. Not SG collision object. SG collision shape 2D is the one that's managing its life cycle. So the shape resource gets set, and then it will actually, well, here it's deleting whatever old shape was there, but then when it's adding the new shape, it will create the shape and actually add it to the collision object, and you know, it deals with deleting it, removing it when it goes away. So that solved that problem. Also, I started investigating something that we had noticed, or I had noticed on the last stream that was worrying me, which was that when you collided on a corner, ooh, it looks like some people are sharing some project stuff. I will check that out in chat, guys, once I'm done sort of reviewing what we did last time. I'm super excited to see what you're sharing. So something that was worrying me was when colliding into these corners, I felt like maybe it was getting the collision normal wrong, because I kind of felt like, you know, it should slide a little bit, like to the left or the right along this face, because I was expecting the collision normal to be a vector pointing out from here, perpendicular with this face. And so, because see, it does like slide right there, but it just seemed weird. I remember Valorzard had suggested maybe we should like paint the collision normals on the screen, which would be really cool, and maybe we should do someday. But I took a different approach. I made a physics test 3 scene, which is very similar to our physics test 2 scene that we've been using, except this one uses the default like Godot core physics engine, and I was experimenting with it and you know, reading out what the collision normals it was giving me and the sliding behavior that it was having, and it turns out it's the same. Like down to like just off by like some really distant decimal points. Like I have it printing to the log here where it would calculate the normal of the collision, the remainder, the slide remainder, and like it was super close. So even though it felt a little unnatural to me, I think that's probably because I'm paying just so much more attention to this stuff now that we're working on it. Okay, I hope that's good. Let me just take a look at OBS. I just adjusted the camera without me looking at it. Don't adjust things when you can't see what you're doing. Then I started working on trying to get the map start positions, because you may have noticed when we did this test earlier, it actually started me up in the corner rather than the position on the map that we're supposed to start. Which here, let me just show that. See, I'm way up in this corner. I'm actually supposed to start somewhere, I don't know, around here. And the way that we have that working in this game is the maps define some position 2D nodes. Let me just show one really quick, which are the player start positions. So like here's one of them. And these previously were position 2D nodes. We didn't have a fixed version of the position 2D nodes. I created one. And that is now, where is it? 2D collision, fixed node, fixed position. So it's just a really like light layer over node 2D that just adds like that kind of special drawing. But to actually use it, to have our tank start in the right place, we need a way to be able to grab its transform and apply its transform on another object, and we weren't exposing the fixed point transforms to Godot, and so I started working on that. That was what was on my screen when the stream first started, because we do have an internal fixed underscore transform 2D object, but I started making one that is exposed to Godot, so that from GDScript we can access it. We can grab it from that position 2D and apply it to the tank when the match starts. So we're going to pick up working on that so that we can get the map positions working, so that we can get everything, all of the obstacles colliding with our physics engine. And if we have time left at the end, we're going to address bullets and see if we can implement bullets. So you guys were telling me about your projects. Let me go check out what we got going on here. Or maybe the Clean was telling me about the projects, assuming this hasn't... my computer fell asleep, so... all right. The Clean is working on a game where you can reflect incoming bullets Star Wars style, like with lightsabers, you're just like hitting the bullets with the lightsaber. Is it a VR game? Because that actually sounds amazing. Although, have you played the Vader Immortal? You can totally do that in Vader Immortal. It doesn't feel particularly great. It feels like the game is helping me a lot. Like the stormtroopers are shooting at you and you reflect it with your lightsaber and it just kind of goes straight back to them. And I'm like, oh, okay. Could have gone anywhere, but it went right back to the guy. So that sounds really cool. And a little collision demo. I guess I'll open it up over here. Oh yeah, totally. It's a VR thing. Let me get this up on my computer that I'm actually streaming. Give me a second. Too many screens, too many desktops, too many everything. Let's check this out. So here's the lightsabers. So you're hitting the stream, which I'm imagining is the raycast. And then those bullets flying out of it, is that the reflection? Is that supposed to be testing the reflection? Anyway, I'm excited to see how this goes. Definitely let me know as you get it further along. That seems super cool. All right, Elliot's looking for his little guy. I haven't paid that much attention to your guys. Let's take a look at your guys. So both me and Inferno, as we previously discussed, had the same shirt. Oh, Agnakos, you look awesome. You're like an orc with some sort of like, that kind of looks like this things the Wakandans wear in in the Marvel movies with the sweet white hair. Elliot Christensen's got, well, maybe some plate mail and no pants. Keeping it relaxed today, Elliot. Good work. And what is the Clean's character holding? I guess that's a shield. It looks oddly like a clipboard. The Clean's got like an orc with a clipboard. It's a very an orc in the factory. No, I'm sure that's a sword. Cool. All right. Cut off workout shirt. Yeah. All right, let's get down to work here. So I guess we need to kill this for now because we're going to be hacking around in C++ a little bit. And we are going to try and take our SG fixed transform class that we just created and integrate that into the inner workings of our SG fixed node 2D class, so that from any of our fixed point objects that you can grab the transform, set the transform. And I kind of have an idea for how to do that. So, ooh, I guess we are already storing a fixed transform. I didn't recall setting that up. So maybe this will just be super easy. Maybe we're just going to be swapping this internal fixed transform 2D for our external SG fixed transform 2D, and then converting to this when we need it, converting to the internal version when we need it, thus allowing us to pass that, into GDScript so users can mess with it. So maybe this will be easier than I was imagining it was going to be. I guess I had forgotten that we had done that. And I thought that the task was going to be going from these kind of individual components that essentially make up the transform. The transform is just a matrix, and kind of putting it into the transform. But it seems we've already done that, which is pretty cool. And then these methods, we're still going to kind of want these internal methods, but maybe we'll rename them to _internal or something like that. So let's give that a shot. Fix transform. Oh, we have to include the H file so that it will autocomplete for us and compile. Both of those things are quite useful. So let's include SG fixed. No. Okay, it's in the same place as the vector, right? Math, yeah. SG fixed transform 2D. Beautiful. And this will be, I guess this will replace our fixed transform. We'll get rid of the old one and that means we're gonna have to convert a bunch of code. So this first step here is just getting our code to work the same as it did before, but with the new stuff. So we won't even, like, the whole reason we're doing this is so that we can expose it to users, but let's start by not exposing it to users. We'll just try to get the same code working, but with this new object. So fixed transform, there is a get internal on there that will get that. Get global fixed transform internal. We might not even need these because all you have to do to get the internal version is call get internal. Although, yeah, like the global one, I don't necessarily want to be converting it back and forth too much. I don't know. We'll see what ends up being the best way as we kind of get in here and explore. So should I change this one to be internal? Update fixed transform internal. I guess so for consistency. And let's jump back over here. Okay, so this changed callback. When does this changed callback happen? When either the fixed position, fixed scale changes. So we'll need to have that happen also too when our transform changes. Let's get started here. Just renaming these things. The clean is explaining his demo a little bit. There is a buffer implemented remembering past sword positions. It's a bit exaggerated for the demo. I don't expect players hitting it frame perfect. Yeah, definitely. Cheating a little bit for the player sounds good. Kind of like coyote time, that sort of thing in platformers. Okay, so we'll just start with the renames here. And this one, rather than setting that, we'll do set internal. So this will overwrite the transform with that data. And then this, I guess we should, rather than pulling it from there, we'll pull it straight from the object that's being passed in. All right, that seems good. Up here, we need to fix some stuff. Fix transform. Get internal. And then we should be able to return. Hang on a second. So get global fix. Okay, so this, okay. So if we have a parent, we recursively call through the kind of parentage chain to get the global fixed transform. If we have no parent, that means our current transform is global. So we just return it. So that makes sense. We need to switch this around. I think we now have a set origin method that takes the external object. That seems good. Set scale, same deal here. Why didn't that work? What are you saying at me? Has no member set scale? That's lame. Okay, so let's go take a look at SG fixed transform 2D. So we have a get scale but no set scale. Oh, because it wants this to use scaled, but is that always like integrating a new bit of scale? Yeah, it's scaling it. It's not setting its scale. It's like scaling it further. We don't want to do that. We want to actually set the scale. So we don't want to provide an API for just plain setting the scale, I don't think. Do we? Oops, I didn't mean to have this showing here. Let me close that out. I guess I'll look at it on my other computer. Let's go look at the Godot docs for the normal transform 2D and see if it has a set scale, because it does seem super useful. Like, you don't necessarily want to only scale it further, but I guess what you would do is you would take it, if you wanted to set the scale on a transform, you would first orthonormalize it, which we'll make both the x and y vectors on the matrix be length 1, which essentially sets the scale to 1. And then you would do scaled, I guess. Transform returns the transform at the basis, orthogonal 9 degrees, and normal. Oh yeah, and it's also clearing shearing. And normalized axis vectors scale of 1, -1. But what if we don't want to clear the shearing and we just want to update the scale? Okay. I do not know how the Godot object gets away without providing a set scale. Maybe we should just provide one, because it just seems we have a get origin, set origin. So okay, we have two choices. We can provide a new API that lets anyone do this, or we can just use the internal objects and just do it. And I'm debating, do we make things more convenient, or do we try to stick with what Godot's normal transform 2D does? I think maybe let's just stick with what Godot's normal transform 2D does, and we'll cheat by converting things to internal and back again. So okay, so set fixed scale, set scale. So then we need to grab an internal version of this transform. So fixed transform 2D, say internal transform equals fixed transform get internal. Then we're going to do internal transform set scale. And then we need to get fixed scale and get its internal. Get internal. And then we need to update the fixed transform by doing set internal. Yeah, so we just sort of cheated around the fact that that API doesn't exist on the external object. And maybe I need to space these things out a little bit. Oops, what did I do here? Fixed transform. There. And get scale is cool. Set rotation. I bet we also don't have a set rotation for the same reason. How would you unrotate transform? I guess you could get the rotation and then rotate the inverse. This just seems like an inconvenient API. How have I never had any problems with this API in game dev, but now when I'm looking at it, I'm like, you know, it should have these methods, but whatever. We made this decision up here. We're going to try and stick with maintaining the same API that Godot has had. So same deal here. We'll do set rotation. We have to do it the same as this does because we deal in integers when exposing things to Godot, because that's the best primitive we have. And then with this special fixed class internally in C++, because it is a much better primitive for, or not primitive, but a much better tool utility for us in C++ land. All right, so anyone see any problems? I think this should work. Let's compile it. The ideal case here is that everything is exactly the same as it was before. We've just swapped the internal transform. Oh, yep, it's not going to work. You know why? Because there are other classes using those APIs. All right. So SG collision object 2D. SG collision object 2D. Looks like I don't have it open. SG collision object 2D. That's in the CPP file. Here we go. So internal shape, set transform, get fixed transform. We'll just get fixed transform internal. Bam. Yeah, we might end up converting these to be like get fixed transform, arrow symbol, get internal, but I don't know. That's good for now. Principle of minimal changes. We're going to iterate. We're going to just tweak things little bits and iteratively get to where we want to go. So this is a different line, 92. No. SG collision object 2D. Global fixed transform. Are we still in the same place? SG collision. Oh, that's collision object. Collision object. Let's go to line 88 first. Update fixed transform internal. Get global fixed transform internal. I wonder if VS Code is like nice refactoring tools. I'm used to using JetBrains projects where I could have like used the refactoring tool to rename all this stuff for me. My experience with VS Code though is it's more text editor and less IDE. Collision object 2D 197. That's what we just did. Collision shape 2D, and that's the one I accidentally did when I thought I was in collision object. I think that was 114. Yep. Okay, let's see if this compiles. Nothing going on in chat while we're compiling. Oh, for folks who are into, oh, okay. I'll talk about it during the next compile. Update fixed transform is not declared. Oh, kinematic body. Let's get over to kinematic body 2D. Line 136. I also wish that like, and maybe it exists and I'm just not that good with VS Code. If there's like a parser of these messages, I could just click on that instead of having to come over here, you know, and type the line number. All right, let's try this. So for folks who are into VR, and I know the Clean is into VR, yesterday, Space Pirate Arena, which is part of Space Pirate Trainer DX, was released, and I'm super excited about this. It's a game mode for Space Pirate Trainer, which is essentially like laser tag or paintball, and you need to have a 10 by 10 meter space. It like won't let you even start the mode unless you have a 10 by 10 meter space, and you can play, I think, 2-player definitely. I don't know if you can go up to 3 or 4-player or whatever, but you can all exist in the same Guardian. There's like a way to sync up your spaces, and then you're like running around playing paintball, essentially. You know, you're trying to shoot the other people. And the idea that there's this big space with no artificial locomotion, like you're just running your body. I'm so excited about that. I get like really bad VR sickness. I love VR, but I get really bad VR sickness, so I can't play with smooth motion. So I play most things with teleport, but the things I love the best are when I just move my own body through the space. It feels so good. It feels like actual virtual reality, like I'm in there. So I'm really excited to try this. This afternoon, I may go to a park before school's let out, so there'll be no kids there, and like try on a basketball court or a tennis court or something. I'm not sure if I'll be able to squeeze that in, but okay. So let's go to we are hitting a segmentation fault. What did I do? Oh, dumb C++ mistake. I forgot to allocate memory. All right, gotta remember, you want to use a thing, you gotta allocate the memory for it. All right, let's kill that instance of Godot. Let's go back to, this would be in SG fix node 2D. We got to go to the constructor. We need to allocate memory. We'll put it at the top, actually. Fixed transform. SG fixed transform 2D. I'm actually really thankful for segmentation faults, you know, because an alternate way for these things to work is to have it just use the uninitialized memory that happens to be there, which is what would happen if you're coding in assembly and forgot to initialize some memory, as I'm doing like a bunch of assembly these days. For my little Commander X16 games, I have definitely had that same problem, but it just kind of like worked, but then did weird things. And it's a lot harder to find without the thing failing with the segmentation fault. So I'm going to add this fixed transform changed thing that gets called here, but we're not actually going to implement it yet. I'm just kind of putting that as a placeholder for the fact that I know we need to implement that. And this should be enough to try this again. The clean. Sounds cool. I need to look up some local VR communities to check it out. Yeah, like, there's the how to find a 10-meter by 10-meter space, and then there is who to play with. So you don't have to play it with all the players in the same physical Guardian. You can play it online. I don't like. I listened to an interview with the developers yesterday on Upload VR. They do a weekly YouTube live stream, and their studio is in VR, and they have all their people in VR. It's really cool. But they had the developers of Space Pirate Trainer there, and what was I going to say? I was going to say something that they said. Oh, they said that there's no matchmaking, that you have to like play with people who are your friends on like your Oculus friends list. So you still like will need to know people who have the game to play with, but they don't necessarily need to be co-located. Although it's probably easier to be co-located with a game that requires like that kind of big space. Okay, let's not crash. Hey, we didn't crash. And can we drive? We can drive. Everything seems like it's basically working. Let me just quick try in the actual game in practice mode, since that is just like a higher level of complexity. We'll make sure we don't seg fault or have issues here. So I'm crashing. I'm crashing right into these trees. All is good. All is good in the world. Okay, cool. So let's go like real iteratively. I'm gonna commit like every change as we make it. Let's make my terminal font huge. That's interesting. It like re-ID'd my stuff. It's actually kind of lame. So in Godot 4, and possibly coming to 3.4 also, I'm not sure, the IDs are turning into hashes, which means that it won't re-ID your stuff all the time. And the TSCN format will be even more friendly for Git and other version control, which I'm super excited about. I'm really glad that those kind of like quality of life things are being integrated. So let me just make sure everything is added. Okay, then I can just do a commit-a. This will be converted fixed transform 2D in SG fixed node 2D to a SG fixed transform 2D. I'm going to get real tired of typing the word fixed at the end of this project. And we'll push that with CI being skipped. All right. So the next step, we need to expose that transform to the user in GDScript, and we need to make sure if the user changes it, that it updates the object. There's something I have not done in C++ yet, which is to expose a property but not have it go to the inspector. And so we'll have to figure out how to do that. I'm sure it's not hard, but a new thing to learn. We're all learning together. Where is fixed node 2D? I am already here. We need to add some public void set fixed transform const ref sg fixed transform 2D p transform. And we also need a getter. Set fixed transform. We don't want set, we want get, because we are making this into a getter now. And this one is const. Does that look good? Looks good, I think. Yeah. And we need to add one of these little changed functions. Exposition change, fixed transform changed. Hang on. We don't actually have a like a change signal or something to grab from the transform. We'll have to make one of those too, I think. Let's go to the CPP file. Yeah, so I'm adding this connect change. There isn't such a thing. There's no signal, so we need to make that signal, which will be really easy. So the transform is essentially 3 vectors. A vector describing the x-axis, a vector describing the y-axis, and a vector describing the origin, which I guess isn't technically a vector, it's a position. And so we just need to like aggregate all of those change signals to the transformed change signal, and everything should work. Let me find, here we go, SG fixed transform to D. We need to declare a signal, which I think we just do in the bind methods thing. I never remember how to do anything in bind methods, so I'm going to go to the last place I did it, which is in fixed vector 2, and copy and paste. There we go. And so at the beginning, we need to bind to all of these vectors changed signals, and we need something to bind them to. So we'll need a protected method here. Void, it'll be like vector changed, something like that. And let's jump back to the CPP. Oh, and because of the way signals work, we actually need to bind that vector changed protected method as well. Where's a good place to do that? Maybe right before the signal. Okay, and so let's do X connect changed. The object is this. String name is vector changed. There we go. So that looks just like in GDScript. So I'm sure for folks who are more experienced on the GDScript side with Godot than the C++ side, that should look super familiar. And then now we just need to implement that method. Let's put these things in the same order as they happen in the CPP file. So I guess that means we put it right here. Fixed transform to D vector changed. Let's implement that. They can probably be const. It probably doesn't matter though, because it's only being called by the signal system, which just uses function pointers anyway, so no matter if you set it to const, it'd be ignored. C++ is a fun language. Every like type or like whatever qualifier you give to something, public, private, const, is kind of a suggestion. C++ doesn't necessarily take your suggestion into consideration, because if something is marked as const, you can easily just change it anyway. Like there's just a bunch of other little magic things you got to do. Or if something's private, you can certainly call it and access it anyway. So hang on, did I do emit signal right? Yeah, I did it right. Too much talking, David. Distracting yourself. Okay, so that should be enough to get this change signal to exist and to work. Let's go back to SG fixed node CPP, and now we can finally connect this signal. We'll need to do something with it. Oh, and like before, we'll need to bind this fixed transform changed here. Oh, we need to bind everything related to the fixed transform. Okay, cool. We'll grab this, get fixed transform, set fixed transform, fixed transform. I see a chat message. I'll take a look at it after I'm done trying to rapidly type all the typing that C++ makes me do. Fixed transform changed. Didn't mean to delete all of that. I meant to delete 7 characters. Ooh, not quite. 8 characters. Okay, so that should be all the binding we need. And we have to actually implement that method. See what's going on in chat though. The clean. Years ago, I won a bet by changing constants with pointers. Yeah. At the end of the day, everything is just memory, just blocks of memory. And C++ will let you change arbitrary blocks of memory to whatever you like. So you can change any constant. You can call any method. It's all just sort of, and it's good. It's good that it has these suggestions, like the const stuff when you're doing things normal and not trying to break the rules, is helpful. It's totally helpful. It can make your code easier to maintain and understand. But unlike, more structured languages like C# or Java, those kind of things. Like although in those you can break through the things too, actually, with reflection. Although I don't know, like you don't accidentally use reflection. You can accidentally use pointers to do things you shouldn't be doing. But anyway, that was Snowpet Games Language Corner, Programming Language Corner. Let's set up this. Oh, and we have this changed callback we probably need to deal with also. Okay. Well, one thing at a time here. One thing at a time. We need to implement our getters and setters and things based around transform. I'm already seeing that like my methods are not organized the way I usually organize them. So we have set fixed position change, set fixed position, set fixed scale, set fixed rotation. Let me put this stuff, I guess. What is this underscore set fixed position? I don't remember that. Okay, I'm gonna reorder these methods so they're in the order that they happen in the H file, or maybe they are already. Okay, yeah, so there's the fixed ones. Then we get to, okay, no they are. I just ordered them weirdly. So we'll start with here's a void sg fixed node 2D set fixed transform const ref sg fixed transform 2D p transform. I should have just copy and pasted that method signature. Save me some time here. And well, let's make this fixed transform. Basic level, we need to do, hang on. So my gut was saying do this, but I think that's actually wrong, because that will update the reference, which will mean this internal transform is now pointing to this external reference, which could have weird behavior, because a user could set that transform and then change it and be like, why did my node move? So I think what we need to do here actually is fixed transform set internal, and then do p fixed transform get internal. So we're copying it by value rather than reference. And of course we need the get version of that. Let me do what I said I should have done before. I'm going to just copy the method signature. Fixed transform. Okay. So those are the getters and setters, and then we need this changed callback, which I think I put before this function, or method, I should say. Fixed transform change. Why isn't it called that? Fixed transform change. It's just not auto-completing it for me, which is lame. Fixed transform changed. And we're doing this funky trick where we are setting itself for the other ones. I don't know why I decided on that funky trick, but we'll keep doing it. We'll keep doing that. We'll just set the thing with its own value. I think probably that is because we're having these setters also do some other updates. So we update the fixed transform. That means we need to update everything else that gets like its data from the transform, essentially. So position, rotation, scale. So we'll set our flag that prevents all of our infinite loops from, you know, if we change the transform and we update the position will say, oh, we need to update the transform, and then we'll just kind of keep going forever. So that's what that flag is for. And if we look at position, what it's doing is it's updating the visual position, which I guess we have to do that too. We have to update the floating point transform. So set transform. You'll need a method for that, I guess. I don't think I made one. Where we do, I guess we'll stick with the, hang on. Let's cache an instance of this internal transform from p fix transform get internal, so that we don't generate that same bit of memory every time. Okay, so we have our internal transform, and then here we'll do something like internal transform get or toFloat. Is that what we've been calling those methods? toFloat. And we'll need to actually implement that. A method to convert from our fixed point transform 2D to Godot's normal transform 2D, which is what all of the visuals are based on. So we need a toFloat method, which, yeah, let's inline it because, like, or no, let's just make it a normal method. Just make it a normal method. I guess we'll put it at the top because all these kind of like internal mangling things are at the top. And so that would be a transform 2D, toFloat const. I'ma inline it. So we want to construct a transform 2D, which is going to be based on, let's look at what constructors we get. Four overloads. Show me them. This is kind of the one we want to use. But unfortunately, like, we're going to have separate objects for each of these pairs. So we'll have to cache them on the stack, which is not that big of a deal. Just more typing. Everything in C++, the solution is more typing. I guess I was inlining that one. So we want fixed vector, or no, so we want vector 2 elements, or okay, so this is vector 2 is x, elements x to float. So what I'm doing is I'm converting each of the vectors that make up, it's not elements? Oh, right. Because this is the external object, not the internal object. Okay, and then I can't name it this. X float. So X to float. There. So we're converting each of the components that make up the vector from their fixed point versions to their floating point versions. Or did I say each of the components that make up the vector? That make up the matrix. We're thinking about the matrix here, guys. Not the Keanu Reeves matrix, which is much cooler matrix, but the math matrix. Okay, so x float x, x float y, y float x, y float y, origin float x, origin float y. Okay. Lots of code to type. Why are you yelling at me? Nope, it's good. All right, so that will convert from our fixed point transform to the normal Godot one. So where did I leave off? That was in fixed node 2D. All right. Hey, the method exists now. Use it. Use it. Oh, because this is the internal transform. Okay, so we need to do, I guess, fixed transform. This internal external separation I think is important from an architectural point of view, because Godot adds all of this like heavyweight junk to its objects, and we want the physics engine to like have a really nice, clean memory representation of what it's doing so that it can be fast. But man, is it annoying to maintain these like duplicates of all of the objects. Clean says Matrix 4 trailer released. I hope they don't break the series with it. I have not watched the trailer because lately trailers have been kind of ruining movies and shows for me. I mean, not ruining, but like taking away like really cool moments. And so I've been avoiding watching the Matrix 4 trailer, even though like my phone's like, hey, you want to watch Matrix 4 trailer? Like every day. But I'm not going to do it, phone. I'm not going to do it. So we need to also set all of the other things here. So set fixed position. We'll get that from fixed transform. Get origin, because the origin is the position. Scale, set fixed scale, fixed transform, get scale, and rotation, oops, scalar. Scale, and rotation is last. Set fixed rotation, get rotation. And so actually, like, we probably don't need to do this set transform, all that code we just wrote, we probably don't need it. Because all of these things will do the same thing. They will lead to the, or will they? Because we set the updating. Let's just walk through the code once. Let's look at the code for fixed position. Goes to set fixed position, which sets the internal value, does updating transform, sets the visual position. So, oh, but it's also going to mess with our updating transform. Okay, I don't think we can call these methods. I think we have to not call those methods. So this is good. Fixed position, say, man, set internal, and we're gonna grab, I guess we can get this from the internal transform, get origin, and scale, fixed scale, set internal transform, get scale, oops, fixed rotation. This will be a little weirder because we'll have to do the integer conversion. This will be internal transform, get rotation dot value to convert it to just a plain old integer. I feel kind of weird that we have to do toFloat here. Like, it would be better on the internal. Like, there's less memory copying if we do it on the internal one. Whereas, so if we look at this one here, each of these two floats will copy some memory, or won't they? No, they won't. They won't copy some memory. Yeah, because they have a persistent. Yeah, we're cool. We're cool. Never mind. Carry on. Nothing to see here. Let's get back to this one. So, okay, so we're updating transform. We update the visual transform. We update all of our internal fixed scale, whatever rotation values that are just kind of, I don't know, there for, I don't want to say convenience, but there for the users to be able to use them from GDScript. And then we need to tell the editor that all this stuff is changed. Fixed position, fixed scale, and fixed rotation. This change notify is what tells the editor to update what is shown in the inspector. So do them kind of in the order that I did them up here. I think this is good. Possibly not. It looks good. Looks good to me. And we don't want the fixed transform itself to be exposed in the editor, and I'm not sure how we do that, but that is the next thing we'll try to do. Variant object fixed transform. We don't want to give a property type hint. Maybe the property type hint is actually what we use to say we don't want to show it. Let's see what the property hint. Let's see what we got. None. But does that just mean no hint, or that it's not going to show it? Because I don't want to show it. Like the don't export me hint here. All right, if that's all the hints we got, I guess none is the best one. But I do not want to see that in the editor because we have it broken up into those other little components. Set fixed transform, get fixed transform. See what's going on in chat. Lean says, I'm watching only the first trailer to try and not spoil it. Yeah, I don't know. When I saw the first Matrix movie, which was that 1999? I can't remember. My buddy says, let's go see this movie. I did not see a trailer. I didn't know anything about it. And it was the most magical experience ever, because when you have the kind of reveal that they've gone from the, you know, sort of hacker, because there are like a lot of dumb hacker movies in the 90s, right? And they go from like, oh, this is kind of another dumb hacker movie. Keanu Reeves is the super hacker and they're going to recruit him. And then they're in a submarine. Like, that blew my mind. That was one of the best moments I ever had watching a movie, because I had no idea that suddenly we were going to, well, I guess it's not technically a submarine. It's like a hover thing. But like to switch like completely from what I thought was a dumb hacker movie to like this just epic thing, and they're on this like alien seeming version of Earth. Oh man, it blew my mind. And it was because I didn't see the trailer. I didn't know anything about it, and I would like to have that kind of experience again. All right, so we got this here. Do we need to do this stuff? What is this changed callback for? Is this for... This is for, okay, so this is for when the floating point version is changed, which we might not need. Perhaps. I'm not sure. So if something changes the floating point transform, do we want to do anything about that? My feeling right now is no, because we know all of the editor tools, at least I think so, will always mess with these individual properties rather than updating the transform. And when we're not in the editor, we don't care. But what if that bites me later? Like something needs it, like there is an editor tool that messes with the transform, and then I'm not going to remember back to this moment where I made this decision. So let's implement one of these. Let's implement one of these. So this is, again, something that should only happen in the editor when the floating point transform is changed. And then we need to do this from float business, which we totally did not implement. So we need to do, I guess, fixed transform from float, get transform, and then set it to trigger all of our stuff. And so we need to implement that from float method. And that's a, how did we do it on the SG fixed vector? From float is just a member. Okay, it's just like we're overriding what we got. Cool. All right, so void. Do we want to inline this one too? On fixed vector, did we inline them? We didn't. I still feel kind of weird about inlining this. Because maybe it shouldn't be. Let's uninline it. It's going to bother me forever. It's going to bother me forever. Okay, so let's just declare this one from float, and we'll do const transform 2D p float transform. And while we're in here, we will copy that stuff, head back here. That was like way up at the top. And we're returning a transform 2D, SG fixed transform 2D, to float const. I think that was the method signature. And we'll implement the new one. SG fixed transform 2D from float. Right, it's const reference. 2D p float transform. And what is the easiest way to do this? So we are 3 vectors. We can get 3 vectors from the float transform, and we can convert them. So let's do that. We will do x from float, and the floating point vector will come from the float transform, and that is the first element. So it's easy. Look at that. Oops, not z. XYZ origin. There. Simple. Straightforward. On to the next thing. Fixed node 2D. Okay, so we have all of this business. I think that should just work. We're not using it for anything, but we can at least verify that we didn't break anything. We can verify that the property exists. So let's compile it. Let's compile it, give it a shot. Is it still running? Probably. I always accidentally leave these things running. Close you. And we are compiling. So I didn't have, ooh, what? Redefinition of 2 floats. I must have written it slightly different. Oh, I uninlined it without deleting the inline version. That's what happened. Okay, gotta delete this code since I copy and pasted it into the CPP file. Okay. So I didn't have any new stuff to show in my Commander X16 game today, which isn't to say that I didn't work on it. I actually did do this massive refactor last week. I'll just see if I can get it running really quick. By some definition of really quick, I am not quick. And so it'll look the same, which begs the question of why I'm showing it if it's going to look the same. Ah, and it's on the wrong screen. But I rewrote all of the collision detection code to be like good for some definition of good. I had mentioned last time that so the Commander X16 is an 8-bit computer that uses a 6502 processor. So I'm making that little game that I was just showing in 6502 assembly, and I'm not very good at assembly. I just started learning 6502 assembly a bunch of months ago. And the collision detection code, the previous one was like 500 lines long. It was crazy and terrible, and I felt like guilty every time I looked at it, but I refactored it into a much nicer thing. Okay, so let's just make sure we didn't break anything. Step A, it went away. Okay, let me I gotta do here. Okay, kill you. How do I get that to come over? Retro Tank Party, this one, yes. Okay. Here we go. Yep, still working more or less. Okay, so now we gotta actually do something with this. And the thing that I want to do with it is do the map start positions. So I'm just poking around in here, making sure everything's still online, because I haven't heard from you guys in a while. I get nervous if the stream is still running. The map start positions. So that takes us to oh, and I want to make sure that that the transform isn't appearing in the inspector. Ah, it is totally appearing in the inspector. How do we make a property but not export it? Okay, so I guess that's the first thing we got to solve before we before moving on to the next thing. Ooh, Ricardo has like a sweet axe. What's up, Ricardo? Does the fixed transform property not show in the inspector? Hey, perfect question. That is what I just noticed. So how do I make it not show in the inspector? In GDScript, it's really easy. You make a get set property, but then don't export it. Node has to do this also, right? Node2D. So let's just go poke at the Node2D documentation, make sure that it's doing what I think it's doing. So global transform is totally a property in Node2D that isn't exposed in the inspector, right? So let's go grab, this is just a Node2D transform. There is no global position there, global transform there. So let's go look at the code then in engine for pressing JetBrains key bindings. That would be in the bind method, or bind methods method. So add group transform. Hey, property hint none. Maybe this stuff is what makes it not go. These two properties at the end. I don't know what the heck those do. I think this is a macro. Ah, what? I want to go look at the definition of this macro, this property info macro. Oh, okay, cool. So property hint. Okay, hint string usage. So this p usage has to be it. This p usage. I bet that's what it is. Ricardo, you're like one step ahead of me. Ricardo says, I think it's done in Node2D. That should show how to do it. Wow. You are lightning fast, Ricardo. Okay, let's jump back to so our fixed transform, CPP, bind methods, property. No, not transform. Blah. What am I doing? Fixed node. We want fixed node 2D. Here we go. This bind methods. All right. And set fixed transform. And if we copy exactly what node had, it's like the type hint string, and then this is the usage, which defaults to 7. I imagine that's some combination of flags, and we are passing in 0. I'm kind of curious though, like let's look at what the other property usages are. Internationalized network. Okay, cool. This is exactly, or maybe not exactly, but definitely like related to kind of the attributes that you apply to a variable. It's like, say it's a network variable. We can say some of these things don't make sense to me. Maybe let's like go look at the actual code. I'm just curious. I want to learn about Godot as I'm doing this. So the default is usage storage, which I bet that's export. Or no, maybe usage editor is export. Let's go look in the docs here. We'll do property usage editor. See what these usages are. Yeah, it's one of these enumerations. usage editor. Okay, so storage means it's serialized to the TSCN file. Editor means it's shown in the editor inspector. So kind of these two together are like the export keyword in GDScript. Network, oh, network's not used anymore. Maybe that was like previously for declaring if a variable could be rsetted or rgetted or something like that. Editor helper. Yeah, most of these are like not very important. So default is 7, so that means 1 and 2, and then network, right? The deprecated usage flag is default. Interesting. Learning new Godot-isms every day. Okay, so we made that code change. And I want to find my way back to our code here and delete this thing that I put here just to get the lookup going. And let's compile it. Of course, killing the old one first. And we are compiling. This one should go fast because we just changed like one line in a single, what do they call them? Translation unit? A single translation unit? I think that's what like the generic term for a CPP file is, or a .o file. Or not. Linking is always slow. So the one thing I did actually fix in this demo, in my Commander X16 demo, is after I refactored the, oh, this is going to get weird if I leave it full screen like I did last time. After I refactored the collision detection code, I was able to fix gravity. So I don't know if you remember before, you would like walk off the ledge and just like fall like a rock. And that was this bug in Gravity that I couldn't fix without refactoring the collision code, because what I needed to do was to say like, hey, is there any ground underneath you? And because the collision code was that one monolithic like 500 line thing I couldn't do. And it's funny because Mega Man 3 had the exact same bug, and I bet I bet it existed for the exact same reason. And it was that we're using these fixed point numbers to describe the position, and of course you with like 16 fractional pixel values, so you can be like on a pixel plus 3/16 or whatever. And so gravity like builds up, and you can't see it building up because like the pixels are rounded between the pixel that the character's foot is and the pixel that represents the ground on those 16ths. So then when you'd walk off the edge, gravity would be actually 16 times higher than it should be, because it would have 16 sort of like units worth of, well, not necessarily 16 times. In my case, 16 times, because gravity is exactly one of those like 16th units. But I guess, you know, if it was 2 of it, it would be 8 times or whatever, but some multiple times higher. I was able to finally fix that with the new refactored collision code. Anyway, enough of that. We're doing Godot today. So let's go to our test scene, look at our character, and there we go. There is no fixed transform, so we're good. Since we're doing this super iteratively, let's make another commit saying that we added fixed transform. Ah! It got added here though. Do I have to save? If I save, will it go away? Oh, whew. Oh, weird though. Rotation turned to -1 on some of these objects, which like isn't necessarily bad, but pointless. A rotation of -1 is the same as a rotation of 0. Or wait, no, a -1 in fixed point values is actually significant. Okay, let's just check this out and hope that that was caused by us accidentally having that in the inspector briefly. So that'll get rid of those changes. And let's add these changes. And I'm just going to make sure that that weird rotation thing doesn't return. So reload, yes. And I'm going to save. And let's just see. Get status. Didn't return. Beautiful. Okay. So, some weird tab issues in here. Probably a mix of me copying and pasting code from different places. Screwed that up. But let's commit this. So added fixed transform property to SG fixed node 2D. All right, now we're going to attempt to actually use it. Let me push this. Skipping the CI. And so gotta go to the map. Here's our battlefield map. And this script is a generic script that's used on all maps. And it has this get child transforms. And it's grabbing a global okay, we need a global fixed transform. Okay. Does that mean we need a whole new property, though? I don't want to do a whole new property. That means more memory to manage, more accessors. We could just have a method. It's not very Godot-ish, though. It'd be more Godot-ish to have a global transform. How does Node handle its global transform? Node doesn't have to deal with as much weirdness as we do because transform 2D is a primitive in GDScript, whereas ours is an object that exists by reference, which means if you do things like, you know, so global transform, I don't know, if you're just like set, you know, something on here, like this would affect the global transform. This is not a good example because, like, what would it be? X? Vector 2, like, you know, something that just made the x-axis be the y-axis. And we can do that too if we go through the trouble of managing this extra piece of data. But we don't want to manage an extra piece of data. What if we just provide getters and setters and like not do this magic for global transform? We'll still have the magic for fixed transform because we went through the trouble of making it, but yeah, because this isn't one of our types. What does chat say? Your character clipped through the top of the screen and started a trip into oblivion. Yeah, I gotta fix that bug, or at least add like a key code to bring the oblivionized characters back. How are we doing on time, by the way? Okay, we have about 45 minutes. I would love to get this thing actually working, and once it is, I think converting the other obstacles to actually collide will be super easy. We just have to not spawn inside of the sandbags. So okay, we so we're making this list of transforms, which we want to actually be fixed transforms. It's honestly, most of the time it doesn't matter if they're global or not. Let's just start by like saying they're not global, even though they should be. I'll add a little to do for myself. Use global fixed transform. And where are these used? Get child transforms from the parent. Child transforms. Where else is this method used? Get child transforms. Oh, team start positions? Okay. Because we have two separate sets of start positions occasionally. Team, player, that's it. Okay. And gotta stop yawning. I don't want to make the all, you know, usually in the end my stream videos get like about 100 views. I don't want to make all 100 people, you know, yawn. That's just not cool. Okay. So where is this actually used? Probably in one of the game mode base classes. But where is this used in practice mode? Because practice mode does things different. Practice. Game setup players, blah, blah, blah. Player 1. Just 1. Maybe it's done in game. Maybe setup players does it. Setup players. Okay, yeah, so we can sometimes pass in player start positions. If we don't, what does it do? Player start positions. What? So start transform, player start positions, player index -1. If player transforms, otherwise, if player index is, oh, and player index is less than anything, otherwise null. Start transform. So what does it do if this is null? Otherwise, it grabs the player start transforms from the map and adds them to start transform on spawn data. Wow, the indirection here. Taking us down to windy, windy field. Oh yeah, because it has to use the sync manager so that we can safely spawn new things in a rollback context. Since rollbacks will need to respawn things that have previously been spawned. So then that takes us all the way to the tank itself, and it will have some special method that's called by the spawn manager. I'm remembering how this rollback code works. Is that under objects? Yes. Tank. To go to tank itself, it'll be called spawn something. Network spawn preprocess. Okay. So what we need to do here, we want this to be global fixed transform eventually, but right now we're just going to do fixed transform equals data start transform. Wow. Okay, how many layers of indirection was that? 4-ish? Let's give this a shot. Come on, work on the first try, work on the first try. You know what happens sometimes. Not it worked on the first try. It happened. Oh, that's fabulous. Wow. What was that? An hour and 22 minutes of typing C++, essentially glue code. Let's be honest here. That wasn't fun, exciting physics code. That was glue code. And we started in the right spot. Sweet. Okay, before we move on, I do think we should do the thing with having global transforms. And we're going to cheat. We're just going to have methods for it, not properties. So we don't have to worry about managing memory. The plus side of that is I think frequently you're not using global transforms and like modifying their properties in place. Because, I don't know. I don't think you are. Let's... We already have the calculation for building the global transforms. We just need to, convert the output on the end. So SG fixed node 2D. You can see we have this get global fixed transform internal. We're basically just going to translate that straight over. So, and that's the getting. The getting is easy. The setting might be a little trickier. We'll have to get the global transform of the parent, invert it, and then multiply that against our local, or against the global transform that's being passed in. But that's not a big deal. So get global fixed transform const, because we're not modifying it. No, we're not going to let people modify it. Oh, and it's not void. It's a ref sg fixed transform. I'm going to copy that up here. And void for the set global fixed transform, which is a const reference, sg fixed transform 2D, p transform. We'll call it global transform. Stream typing. Okay. That should be all good. Why are you mad? SG fixed transform 2D. What? What just happened there? Okay. And let's bounce over here. It's interesting. We have this update fix transform internal and this set fix transform, which does, I think, exactly the same thing. I wonder if we could have just had this method call that method. It does the exact same thing, just like a little bit differently. Let's try that. I'm just gonna comment this out and replace it with calling that, and we'll see if it still works. So that was update fix transform internal p fix transform get internal. I did not realize that that method does exactly the same thing until I'm looking at it. Like, it doesn't do the change notifies as separate things. It does the set fix position stuff, set fix position, set fix scale, set fix rotation, which will do that under the hood. This is just a lot easier to read too. That's a lot less messy looking. We wrote some code we didn't need to write, but if in the end we can delete that and have less code, that's a net good thing. Okay, so set fix transform should come right before, or set global fix transform should come right before set fix position. Set fix position, okay. So I'm going to do the smart thing here and copy and paste for a moment. Copy and paste these two definitions. And where am I? Oop. SG fixed node to D. And wait, not set fix position. I copy and pasted the wrong things. Set global fix position. Get global fix position. And I called this global transform. Okay, so set. We need to get the parent's global transform. So let's go look at the get global transform thing and kind of see how we get the parents stuff. Yeah, okay, we'll take the same structure of this, but then just replace what it's doing, which it's checking if it has a fixed parent, and if it does, then it does some stuff. And we just need to do this a little bit differently. Inverse times the p global transform get internal. And we're not returning it, we are setting it. So fixed transform. Or okay, we'll use our magic update fixed transform internal with this. Right? Oops. That's code. Just saw the clean said something. I want to check just in case I'm missing like some amazing insight from your character. Or no, what? I saw a new thing happen. Did my computer go to sleep during the new thing? Oh, the clean's got a head out. Thanks for joining us, the clean. Catch you later. Oh, there we go. Now my other chat window has updated. I have Discord and the Restream chat client open on my little Chromebook there. Okay, so if we are not having a fixed parent, updating the global transform is the same as just updating our normal transform. So update fixed transform internal, p global transform get internal. Oops, internal. Okay, I think that's right. The one thing that I might have gotten wrong, because I get it wrong all the time, is which order I should be multiplying these two matrices. I think this is the right order. Because we want to have the global transform, and we want to move it by the inverse, and you do matrices backwards. So when we multiply this one by this one, we're actually starting with this one and modifying it by this one. So Hopefully I got that right. And here, this should be even easier. We're going to return a new reference delimAbob. Mem new sg fixed transform 2d, which is based on get global fixed transform internal. Taking advantage of code we wrote last time, or maybe the time before last. Okay, so get global transform, set global transform. We need to bind those methods to make them available to GDScript. I will just steal these ones here. Copy, paste, modify, the usual thing. Get global fixed transform, get set global, global. That looks good. Let's kill our current Godot editor and recompile and see what we get. Oh, I missed Aknako saying, "We are here," with the hand-raising emoji. Thanks, Aknakos. That was probably during the part where I was thinking no one was there. Oh, what did I get? Compile error. Too many or not enough parens. Let's get to where those parens are. That looks like 143. What? 143. There we go. So not nearly enough parens. Okay, one too few. Let's give it a try now. Have you guys been playing any cool games lately? I have not had a lot of time to play games lately. I've been mostly playing VR games with my pa, who is in his 70s, and really into VR games. He's like never played any video games previously, and I got him into VR, and now he's like super into them. And it's funny because like his favorite game is Into Death, which is an action roguelite game, and now he knows the term roguelite, and so he's like cruising the Oculus store looking for other games that describe themselves as roguelite because he really likes that genre. And it's funny for him to go from no video game knowledge at all to like a really niche video game genre term being something that he's like really into. So like the last VR games I was playing was with him. We were playing a new action roguelite VR game called what was it called? Dread something. It's like this sort of horror sci-fi thing, which was just whooping us. All right, so I changed some things. We need to change some more things. First of all, actually, let me just run it as it is, because I did that thing where I replaced that one method, replaced its code with just calling that other method. And so, okay, cool. So that seems to work. That seems to work fine. And then we're going to change some other code that we had changed in the maps. Where the heck is that? So we'll go to mods, we'll go to core, we'll go to maps, battlefield. This is how I find my way to the script, which is located somewhere totally different. If I hover and see it, yeah, source components. Did not remember that. Okay, so we're going to change this to use global transforms. Say get global fixed transform. Call that method. Does it like really know it exists? Well, I don't know. I can't tell. And let's then do set global fixed transform over, where was that? The tank's spawn process thing, or whatever that is called, the thing that gets called by our spawn manager for rollback, or rollback spawn manager. Okay, and so then this is going to turn into set global fixed transform. That should be good. Let's run it. And we'll see if it explodes. Works perfectly fine. That's 2 times! It just worked on the first try. When does that happen? Jeez. Okay, cool. So let's commit this. We have fully converted the map starting position thing. Let me just take a peek at the code really quick. I like looking at the diff. Oh, okay, so I commented this out. I'm actually going to go and just straight up delete it because I was just commenting it out in case it turned out to be no good. Make it easy to revert. But if we don't need that code, let's just not do it. Bam. Okay, and let's take another look at the diff. Yeah, this is cool. This is good. Let's commit it. Use global fixed transform for map starting positions. Cool. And I think there's some other places where we might need to change how those are used, like in the team mode. But like this is good enough for now. That's just a crash waiting for us later that we'll debug once we get to making sure that the team modes all work. So we now get to get down to like converting some stuff. It's 11:36, converting some obstacles, that is. We're getting like really close to actually going through my list of tasks I planned in advance, which is unheard of. Let's get to these obstacles. That would be objects, obstruction. So we have, why is that the tree in here? Oh, because I split them between obstruction and cover? I guess. Obstruction is things you can't drive over, and cover is things you can't drive over and shoot over. So let's bust into here, switch over to our 2D view. We are going to convert this static body 2D to our custom SG static body 2D from our custom physics engine. We are going to add an SG collision shape 2D, which I think I'm going to rename. Well, I'll rename it after I convert this. So this rectangle, 28 by 27, we'll add our SG rectangle, which times 28. Was it 28 first or 27 first? 28 first. Okay, good. I think I did that right. And then this one, the fixed point version of 27. And I should, like, this control that shows the fixed point numbers is a custom control. It's a custom editor plugin. I should put something in there to allow us to enter normal values and not have to deal with these literals. But I kind of like the literals insofar as I know what I'm dealing with. It's clear that these are these magic fixed point numbers, that they're not floating point values, but usability, it would be better to remove them. Anyway, so now we can delete this one, and we'll rename it to collision shape 2D. There is no script here. I actually want to see on the tree, did I leave it named SG? Yeah, I don't want the SGs in the node names. Let's get rid of those. And it has a script, so let me just make sure we're not using it. Ooh, this we can remove, I think. Let's see if we can remove this. And for the positions to take hold, like we learned last time, if we go to the map, it should convert them for us. So these crates, if I now save, let me just go look in the TSCN file, see if it automatically converted the positions from floating point to fixed point. Maps, battlefield, TSCN. So we're looking for metal crates. Metal crates. Metal crate, position, and a fixed position. Beauteous. Beauteous. And has a fixed rotation, which looks roughly right. Like, I can't do that math in my head. I can't do 0.047226 times 65,536, but it seems a lot roughly correct. Cool. So the conversion went. All right, now let's just try this because I removed that sync to physics engine that we had added when we were debugging stuff last week. When we were trying to figure out why the tree collisions weren't working. I suspect we don't need it at all. We do not need it at all. Okay, cool. I'm just going to go delete that code completely. Tree big, script, get rid of ya. We don't need to explicitly sync to the physics engine. It will happen automatically. which we know because the crates have no script. Don't do that either. Oh, I didn't test that the crate collision worked. Let's run into a crate. Hello, crate. Yeah, I slid right off that crate. Yeah, there we go. Perfect. Okay. Let's convert the rest of the things. So we have the small tree. We will convert this to an SG static body to D. And we will add an SG collision shape to D, which will take a new rectangle shape. And we will copy the values from here. It is 33 by 34. So I'm always going in here and doing 65,536 times the value. So 33 times 34. And they start with 65,536 times 10. So I'm just deleting the 0 and multiplying it, if that isn't clear from like watching on the stream. All right, so now we can delete this one and rename this one, and we are golden. Let's get to the barricades. We'll do the metal barricade. Same deal. Static body to D. Oh, nope, wrong static body. SG static body to D. Then add SG collision shape. Again, a rectangle. And let's copy the values. 29, 28. There seems to be this consistent thing where like X is 1 pixel wider than Y. I don't know if I did that or if Kenny did that, because this is a Kenny asset pack. Anyway. So 29, 28. 29. 28. All right. Barricade wood. It's a lot of just monkey work here. But I am a good monkey. SG collision shape. I'm so happy that this just works, though, that the editor does this this conversion for us. Otherwise, we would have been writing a script to do it, probably a Python script, which, you know, would have been a fun thing to do on stream also. 29, 28 again. But always, if I can just not, I would happily not write a script. And there's not that many to do. We have 3 left. 3 more to go. And because like how long and crazy working on this Git branch has been, I think when I finally merge this into the like main repo on the branch, I'm gonna like squash merge it. So like the amount of these changes is just gonna look crazy. Because I do not want like the, you know, 500 commits or whatever that we've done while trying to change the network synchronization. 48, 15. Kind of looking forward to seeing that diff. Big squash diff. All right, that is the red fence. Now for the yellow fence. I could have made these be the same scene. I don't know why I didn't. Funny choices you make while developing a game. There's always the... What did I just turn that into? Undo. Let's make sure I didn't do that up here either. No, that's collision object. That's... Wait, hang on. This is static body. Okay. This I want to have become... Wait, why am I not... Okay, get over to yellow. Okay. Talking and typing, always problematic. SG static body. Collision shape 2D. Oops. Now I'm just starting to make dumb mistakes because I'm doing too much monkey work here. Shape 2D, It's a rectangle. Let's look at the values here. 51, 15. So different than the other one. The last one was 48. Maybe that's why I made them different scenes, because they were different sizes. So 51, 15. I never use this editor description field, but it's like you can put comments into the scene tree, and that would have been a really great comment to be like, I made this its own scene because it had different sizes. But I've literally never used that. Do you guys ever use that? The editor description field in the editor to put like comments on your scene? Change type. SG static body 2D. I did that right. Let's add SG collision shape 2D. 3222. Add a rectangle shape 2D. 32. 22. Let's clear this one out. Rename this one and save it. I'm a little worried that I should have had the battlefield closed while I was modifying the scenes that are used in it. Ooh, it had a little updating scene dialog. Maybe that means it just got it. Like it just did all that for me. Let's like look at the sandbag, hover over it, see what it says. SG static body 2D. Seems like it might be good. I'm gonna press it, or maybe I'll add this stuff to Git before I press it, just to make sure it does what I want it to do. Okay, now save, and now I'll do git status. So it changed the battlefield. Let's look at the diff, and it added a fixed position and fixed scale to all of the trees and stuff. The crates it did last time to the fences, to the barricades. All right, that looks good. Let's what'd I do? What'd I do? Let's test it. Running the game here. Bounce over into practice mode, and there is an exception. Okay, so everywhere there's a script, we need to update the class name used for the script. So that was one. Tree small, I guess, has a script. Let's just quick look at the rest of these. No script. Tree big, but we already converted that one. Tree small, but we just dealt with that. Barricade. Oh, what did I do? I forgot to delete this one. Let's delete this one here. I guess this is good given a once over. Find my dumb mistakes. Barricade wood. No script. Fence red. No script. Fence yellow. No script. Sandbox? Did I really name it Sandbox? I meant to name that Sandbag, but I called it Sandbox Page. I love also that this is the first time I've ever noticed that I accidentally named it Sandbox. Okay, who cares? It's fine. It works. I've never noticed before, so clearly it's not that big of a deal. Let's see if we collide. Oh, we are colliding with everything. Look at that, guys. We, how long ago did we set off on this adventure to create our own custom deterministic physics engine? And it is colliding. Things are happening. Wow. Okay, so it's still going to drive through that because we did not convert those. Those are not obstacles or what was this? Obstructions or cover. That is really going to need us to work on our shooting, though. I mean, I guess we can convert them now. But there's like... Let's not convert it now, because there's the whole thing where it spawns them in a particular location, and it's randomly choosing the location, and it's using not fixed point math to do that. There's a bunch of things that we'll need to change for the boxes. So let's just leave it unconverted, so that when I go there later, I won't think that I converted it and wonder why it's not working. I'll just know that I didn't convert it. It's unconverted. But what we can and should do is make the rest of these maps update. Or we'll do this iteratively, like we've been doing. I will commit that we converted all of the obstructions and covers. Converted all obstruction and cover on battlefield map. We will push that, skipping CI again. I'm gotten into the habit of skipping CI most of the time now because it will actually like launch 6 or 8 or some number of servers on EC2 whenever I run CI in order to compile our physics engine on all of the different platforms, Windows, Linux, Mac, and of course then the Steam versions. It's got to do Windows, Linux, Mac, Steam, and then the HTML5 version. I don't want to do that. I don't want to pay the 5 cents every time I commit. I don't need a 5-cent tax. All right, so like I was saying, we should convert the rest of the maps. So we'll go to the desert. All we have to do is visit it and save. Oh, no, we have to do a little bit more. These start positions always need to be converted now into so right now they are position 2Ds. We need to convert them into SG, fixed position 2Ds. Can I convert more than one thing at a time? Can I do change type? Ooh, is this gonna work? That'd be so cool. SG fixed position 2D. Huh. Godot, you amaze me. Things that I would be like, obviously that's not gonna work. Sometimes they just work. Okay, so I think that converted the desert. This one has no team positions, so we don't have to worry about that. The football map, which is not in the is not exposed in the release version of the game, but we will convert anyway. So one of the reasons I started down this whole like rollback and prediction netcode thing is because of the football game mode, which is still unreleased. The game mode works where someone is carrying the ball, they got to carry it to the goal, right? If you shoot them when they're carrying the ball, they drop the ball. And the current netcode sometimes misdetects collisions. And not misdetects. What it's doing is it is using the player who is getting hit as the authority for whether or not they've gotten hit. And I felt like that was the most fair. But it does mean that you can shoot the other player and hit them and have it not actually take health away from them. And it doesn't happen that often, and it's not very obvious. It's very hard to notice. So like it's never been a problem. That sometimes you shoot another player, you see them get hit, it does like the little flash and everything. And the explosion that you get when you hit versus the explosion you get when you miss. So like people think they've hit and whatever, and like maybe, a handful of your hits aren't actually hitting, but nobody's ever really cared. Not really. But in this mode, you'd be hitting the other person with the ball and they're just running, they're just keeping the ball. And particularly because the way people would drive when you're chasing them in this mode, because they'll be zigging and zagging, and the reason that you would hit them and not get a hit is because their position on your client shows a hit, and their position on their client doesn't because they've moved back and forth. They're zigging and zagging. So it just like dramatically increased both the probability of this thing happening and the obviousness of it happening. That I'm like, this netcode is not going to work for football mode. And so that's why I was like, let's try rollback and prediction. Of course, there are a number of other netcode options for fixing that problem, and I did not go down them. I figured I'd try the rollback and prediction first, and then if it was too hard or like didn't work or whatever, I'd like, okay, I'll go try one of the other ones. And I wanted to do rollback first because I've always wanted to do rollback. But man, has this turned into like seriously like an adventure. I'm like, oh, I could probably do that in like 2 weeks. And it's been months at this point. But whatever, it's a fun adventure. In the end, I'll have some cool assets for the Godot asset store to share with the world, some new tutorials to make. I'm particularly excited about, you know, having those assets and making those tutorials because a lot of people do want to do rollback and prediction netcode, mostly again for fighting games. This is a really weird game to do rollback and prediction for, but I think it would be so cool to have like a Godot like thing. Like you just go, you know, you want to do rollback and prediction, grab this asset, go check out this video, and have that be a thing that's available to the Godot community. All right, I'm doing a lot of talking. And how are we doing on time? Ooh, we got 5 minutes left. So we will not have gotten to the last thing on my list. Oh, look at all them trees. So many trees. So this map, our physics engine doesn't have a broad phase currently, which means that for every single object on the map, it's like looping through all of them. So your tank moves like 10 pixels, and it says, okay, let's loop over every single other static body in the map and see if it collided. Nope, no collisions. Okay, let's go to the next frame. And this map with these trees, there's like hundreds of trees. I think like maybe 200 or 300 trees. And so that'll run horribly here. But I think this next week, I'm going to start working on the broad phase. I kind of, I don't know, got tired of staying so deep in the physics engine and wanted to get more back into game, and that's why we've not done the broad phase yet. But it'll probably be something grid-based. So the way it'll work, and I talked about this last time or maybe the time before, that rather than checking every single other body on the map to see if you collide, you will just check the other bodies that are in the same grid cell. And that will make collision significantly more performant. Not that there seems to be any performance problems so far, but that is definitely something that we are going to add to our physics engine. So SG fixed position to D. And I may have just converted all the maps. So let's quick look at those in Git. We'll do a git diff. And this is desert. Seems good. We don't have a good way to test these other maps presently. I mean, we could try testing it the normal way, which is like start 2 clients and see if it works. But I strongly suspect it's going to crash. But let's try it. Let's just give it a shot. We have 5 minutes left. What can we lose? The thing that we didn't get to on my list was starting on bullets, which is going to be hugely important for you know, the game getting that detection into the physics engine. And what will be really interesting is like what's the name of the rail gun, the one that ricochets off of objects. That one will be very interesting to convert to our physics engine. That's what we'll need to implement the raycast in our physics engine for. But I think raycasts should be really, really simple. We'll see. I thought making a physics engine would be simple. Okay, let's try this. Let's run one instance. Let it get going. Then I'll come down here and I'll have to make sure that I run our custom compiled Godot with our module in it. So that will be in Godot 3 bin Godot. It will be x11 not opt tools 64. And this should allow us to start up a second client. And let's battle. See how it goes. I just saved in here. Let's see if I can remember my testing password. That work? It worked. And actually, let's quit this and start it over, because having logged in there will save the password for next time, so I don't have to type it twice. Okay, let's do, why not a private match? And we'll copy, we'll join the private match, join. So far so good, we haven't crashed. Yeah, fine, whatever. Let's go to a different map. Let's go to the desert. Oh, I really want to see maze. Well, let's try desert first, and then we'll see maze. It didn't crash! And I'm colliding with all the junk? Oh, you know what we haven't tried is colliding with other bodies. We haven't tried kinematic. Oh, it just works. Colliding one kinematic body into another. I think Godot's physics engine will actually allow kinematic bodies to push each other. And also note the weird overlap that you're seeing between the two tanks is because we made a new collision shape. Before there was a polygon collision shape rather than a rectangle, and reconverted it to a rectangle, which is, we maybe didn't do it quite well enough. We should maybe adjust how that rectangle is, because it is weird seeing it like slightly overlap the objects it's colliding with. Yeah. Anyway, so far so good. Let's exit this round, and then we will do the maze map. Now, this is going to be our physics engine with our totally unoptimized code without a broad phase. Let's see what happens. I'm driving around. There was a little bit of a lag when I was turning. Oh, why are we driving over the sandbags? Are we colliding with anything? Ooh, we're stuck. Something is wrong here. So I can see the collision shapes, and we're just rolling right over them. And then we hit... Oh, there's the performance hit. There's the performance hit. So we're hitting the trees. We're not hitting the sandbags. Network sync also seems to be a little weird. Like, shouldn't I have seen myself already? Where's my other tank? Oh, man. Okay, well, this is broken. Well, it would not be a stream without us breaking something terribly. So let me just... I want to go see if the sandbags are working in other maps. I thought they were working when I tried it on Battlefield. Let's go try it again. Yeah, sandbags are working here. Wow, that's a mystery. That's a mystery. I wonder if it's a problem in our like global position calculation. But yeah, so this gives us a great to-do item, I guess. I don't know, it's gonna keep writing stuff to my terminal. Let's exit out. And let's look specifically at maze really quick. And let's look for some sandbags. So the sandbags had their positions updated, seemingly correctly. It's interesting too how we see the rotation change slightly, and that's probably due to this number not being possible to represent in our fixed point math, and then this number being the only number that's possible to represent, so it changed. So it's got to be something else going on there. I wonder if like this object's north wall has a position, and our global position calculation is broken somehow, and that's what's breaking it. But okay, let's add our to-do. Have to put in game. Yes. Yes. So we'll see. We'll add a thing, debug. Debug collision issues on maze map. But I'm amazed that it we are able to launch like a normal game with our engine and have at least some of the maps work. This is looking good, guys. This is looking good. I think if I really like focused for the next like 2 weeks, I think I could probably fully convert the game, finish the physics engine, and then it's just down to playtesting and bug crushing and all of that. Oh my god, you have no idea how great it feels to like kind of see the end in sight for this. Like, I was super excited about this project at the beginning, and especially when we were working on the netcode, because like I love working on netcode. Netcode is my jam. But wow, okay, cool. Let's commit this. Converted the rest of the maps to new physics objects. Let me take a look in chat to see if anyone has anything. No, don't push. Push with CI skip. Push with CI skip. Hang on. Let's just make sure that didn't launch a build. I mean, I guess it's fine if it launches one build. I can spare the 5 cents, but I guess I just want to know. Now I just want to know. Skipped it. Bam. Okay. Let's see if anyone has any parting thoughts in chat. And new messages. Yes, refresh the things. Yeah, Ricardo says it's all coming together now, although I think you might have said that quite a while ago. I didn't notice. you could have skipped football mode in a tank game, but I like your decision better. Yeah. You know, what is the game, Elliot, if you're still around, that we used to play? Um, Brawlhalla. Brawlhalla. It's like a multiplayer battle thing like Smash Brothers, and it has a football mode. And playing that football mode was so much fun. I loved it. And I'm like, well, I have this like party game, you know, kind of tank thing. Like, I need a football mode because that football mode was so fun. And so that's kind of where it came from. The football mode has more than technical problems, though. The last time we play tested it, Shipstar, Kyle, is a wonderful tester. I don't know if he still hangs around the community or he, you know, is doing different things now, but he helped playtest a ton, and I'm hugely thankful for all of the help that he gave. But like he just found every way to break the rules of that game and play as cheaply as possible. Like he made it so clear that the rules in the football mode were just broken and needed some serious design rethinks. So after we finished the technical problems with it, then I'll have to go through. I have design notes in my notebook somewhere of all the things from those playtests that need to be fixed for that mode to actually be fun. But man, that would be so sweet to get a solid football mode in there. Yeah. Anyway, guys, I think that's a stream. I think that was a stream. It was a wonderful stream. Thanks everyone for coming. And I think, yeah, we'll see how much I can, you know, heads down code between now and next week, and let's get this thing done, guys. The end is in sight. Let's make this happen. Thanks again for coming. I will talk to you guys later. Bye-bye.